We're going to be learning, we're starting with theme 2, that is the natural environment. And so we're going to be learning how to describe the main types and features of earthquakes over here. And volcanoes is for another video. So before we get into learning about earthquakes, we need to know some background information. So you need to familiarize yourself with the structure of the earth. So the earth has 3 parts. So the first one is the inner core. So the inner core is the widest section. And you don't need to know the information that I'm going to give right now by word, but a good understanding would be enough. So the inner core is the widest section of the earth. And it's made of magma. Then we have the outer core, which is made of liquid nickel and iron. And there's a lot of high temperature and pressure in the outer core. And lastly, we have the crust. So the crust is solid nickel and iron. And it's on top of the mantle, basically. So the crust is actually, you can divide the crust again into 2 types. So there's 2 types of crust. The first one is continental crust, and the second one is oceanic crust. Now the crust is once again something that you can split into plates. Alright, so if the continental crust splits into a plate, we call it the continental plate. And if the oceanic crust splits into a plate, we call it an oceanic plate. And this part over here, this section where these 2 plates meet, we call it a plate boundary. So if this is our Earth, and there are many plates around. The Earth is made of crust, right? So there's the crust, and then you can sort of draw or understand the plate boundaries better if you plot the lines on a map of the world or on the figure of the Earth. And so each of these boundaries are going to be plate boundaries. And so there's a lot of plate boundaries around the entire world. And so what happens if you plot these lines on the map of the world? It will look something like this. And so as you know, each plate would have a different name and a different type. So this could be continental, this could be oceanic, continental, oceanic. So I'm just saying it randomly, obviously. Now, the thing about these plates is when they don't always stay still, they move around a lot, right? There's constant movement at these boundaries, at these areas. So when they move, we call it tectonic. This movement is called tectonic movement or tectonic movements. And so Now I'll explain to you why tectonic movements happen, and I think you should be well versed with this as well. So what happens is basically something called a convection current takes place in the mantle. Now if you remember, the crust sits above the mantle, right? So the core heat, that is the outer core and the inner core, it makes the mantle rise. In a current, and in a current, like sort of a wave-like form, a wave-like energy is what I mean by a current. Then what happens is, as the current gets closer to the surface, it gets sort of cools down. And the cooled current, or the cool air, it travels under the plate and it pulls them with it. Then what happens is, when the convection current, or when this current cools down more, the current moves back down. So it's sort of like, this is the cool current and it's moving this thing up, and so it's getting cooler, and so it's pulling it down. And so this process, it kind of repeats. So the temperature increases, and so the plate moves up, decreases, moves down, up, down, up, down, and so tectonic movements occur all the time. So I'm just going to finish writing that. So this is basically how tectonic movements occur. So this phenomenon, or this thing called convection current, takes place. So first, the heat of the inner and outer core rises the mantle, and the closer the current gets to the surface, the colder it becomes. So it travels under the plate and it pulls these plate boundaries. It pulls these continental and oceanic plates, and then it cools down more and the convection current moves back down. So there the temperature increases and it rises again. So when the plates move and meet at plate boundaries, so as we said, they keep moving here and here, right? So what happens when they meet at these points? At these points, they cause earthquakes and volcanoes. And there are a few exceptions to this idea. So not all earthquakes and volcanoes are found on these plate boundaries. There are some hotspots around the world, such as, areas of weakness within a plate itself and not outside in the boundary. So in those hotspots also you can find some earthquakes and volcanoes. Now we need to talk about the types of plate boundaries. So the first plate boundary we have is constructive plate boundary. And so I have inserted an image of what it would look like. So here's what happens at a constructive plate boundary. So as you can see, these are two plates. And so at a constructive plate boundary, these two plates move apart from each other. And so it causes this area, which we call the floor, it causes the floor to start spreading. And so new oceanic crust, that is this part, starts forming because it goes up, right? And it creates something called mid-ocean ridges. And so at constructive plate boundaries, volcanic activity is quite common. So to summarize that, at a constructive plate boundary, two plates move apart from each other, causing the floor to spread. And therefore new oceanic crust is formed. And when these crusts are formed, mid-ocean ridges are created. And at constructive plate boundaries, volcanic activity is quite common. And an example of a constructive boundary is the Mid-Atlantic Ridge. Next, we have a destructive plate boundary. And here's what happens at destructive plate boundaries. So what happens is a continental plate meets an oceanic plate. Then the oceanic plate, that is this one, it moves under the continental plate because the oceanic plate is quite dense. So after it moves under, it sinks and it melts. So new magma is formed, and the magma that is formed, it escapes to the surface as volcanoes. And at destructive plate boundaries, deep sea trenches are formed. And so as you can see here, these folds, right? So this is the continental plate, right? So because this whole pushing under thing is happening, it's sort of like shrinking the continental plate. So the continental plate folds into something called fold mountains. So let me recap that. At a destructive plate boundary, the oceanic crust moves towards the continental crust, or you can also say oceanic plate boundary. And as it moves, it sinks beneath it due to greater density. So as a result, deep sea trenches and island areas are formed. And then the last point you can mention is that the continental crust folds into fold mountains, and volcanic activity is quite common. The next plate boundary we have is a collision plate boundary. So this is a collision plate boundary, and as you can see, we have two continental plates here. And unlike the previous plate boundary, which was the destructive one, since both of them are of the same density and strength, one cannot move under the other or anything like that. So it's sort of explosive, and thus the term collision, right? So what happens in a collision plate boundary is the two continental crusts, they collide into each other, and since neither of them can sink down into or under each other, they form something that we call fold mountains. So this is a fairly simple plate boundary. The next plate boundary we have is the last one. So there are 4 plate boundaries. The last one would be a conservative plate boundary. So this picture right here depicts what a conservative plate boundary would look like. So if you can see carefully, the dotted line represents 2 plate boundaries. And what's happening here is, as it says, this one, it's slipping. So it's slipping past each other, basically. It's going past each other sideways. And as they go past each other without colliding or without sinking into each other, nothing is created. and nothing is destroyed. So I'm just going to write it down. I want to write that two plates slip sideways past each other, and because there is nothing to be sinking or colliding, what happens is land is neither created nor destroyed. And in other words, there are no volcanoes found along these plates because magma cannot be found. As in, magma cannot escape, because if magma had to escape, there needs to be some sort of opening in the plate boundary, right? So they're slipping past each other and there's going to be no opening because they're not colliding, which would cause it to crack or break apart. Neither are they sinking, which would give some sort of opening for the magma to escape. So there are no volcanoes around the conservative plate boundaries. But however, earthquakes do occur, so you can write that there's no volcanic activity. And so these are the 4 plate boundaries. So just to recap, this is the first plate boundary. That's a constructive plate boundary. So in a constructive plate boundary, 2 plates move past each other and they cause the floor to spread, and therefore new oceanic crust is formed. Mid-oceanic ridges are created. The next one is a destructive plate boundary. Here, the oceanic crust moves towards the continental crust and sinks beneath it due to greater density. At destructive plate boundaries, deep sea trenches and island arcs are formed. And in the end, the continental crust falls into fold mountains. Next, we have the collision plate boundary. Here, 2 continental crusts collide into each other, and since neither can sink, fold mountains are formed. Next, we have conservative plate boundary. So here 2 plates slip sideways past each other, but neither land is created or destroyed, and there's no volcanic activity over here. So now let's move on to earthquakes, and we're going to talk about how earthquakes are formed. So usually you might get this for a 6-mark question. So before we talk about how they are formed, let's talk about a few features of earthquakes. So as you can see here, we have an image that shows you the features of earthquakes. Let's talk about the first one, the focus. So now the focus is a point within the crust that is over here, from which an earthquake begins. Next, we will talk about the epicenter. So as you can see, you go up and it's on the surface of the earth, directly above the focus over here. So the epicenter is the point. Give me a second. So the epicenter is a point, or the point actually, on the surface of the earth, and that is directly above the focus. Now because it's directly above the focus, so as we said, the focus is where the earthquake begins, and being in such close proximity to it, this is where the earthquake is felt most strongly. So if an earthquake happens, you want to stay as far as possible away from the epicenter of the earthquake. And when we talk about earthquakes, we always, as in case studies, when we talk about earthquakes, we always say that the epicenter was at this place or at that place, and it's extremely important that we mention it. Next, we have seismic waves. So as you can see, these waves over here, so these are movements passing through the Earth's crust coming out of the focus. Now we are going to answer the age-old question, how are earthquakes caused? So here's what happens. So when two plates try to move past each other, the plates become locked. And so they stick together, or they literally cannot move because they're that close to each other, right? So what happens is, as they are locked, they try to move away from each other. And when they try to move away from each other, pressure increases because of the energy or because of the attempted movement. And eventually, at some point, they are able to move from each other because the pressure is finally released. All the pressure that's building up, it's finally released, and so the plates, they kind of jolt like a little shock. And what happens when the shock happens, from the focus, shock waves are sent. And we talked about shock waves over here, right? So these shock waves are sent all the way above, and then we can feel them as what we call seismic waves. So if I just explain it with a diagram. So I said that an earthquake happens when these two plates, just an example, they try to move past each other as these arrows depict, right? And so as you can see, at this point, they kind of become locked and they can't move, right? So what happens is it's going to be an increasing pressure, and eventually at one point the pressure is released, and these plates, they kind of just have a little jolt, a millisecond of a shock. And that millisecond of a shock, or that jolt, it sends shock waves from the focus and all the way up to the epicenter. And these shock waves to the epicenter are felt throughout the plate, right? So that's how earthquakes are caused. Now you need to write this in a comprehensible way, and you can do this by splitting your answer into 6 steps. So firstly, write that two plates are trying to move past each other, and the plates become locked. Then pressure builds up as the plates try to move. And shock waves are sent through the crust from the focus. And lastly, you can say that the shock waves are felt most strongly at the epicenter on the surface. So if this one was designed, this answer was written for a 6-mark question. So obviously you can adjust it to a 4-mark or 5-mark question, but no matter how many marks it is, if you are asked how earthquakes are caused, then you need to cover all these points. Now let's talk about earthquake hazards and effects. So what exactly is a hazard? So a hazard is when people, animals, or property are at risk. So I'm going to draw a table to help illustrate the hazards. Of earthquakes. So as I said, a hazard refers to a potentially dangerous event or process, and it becomes a disaster once it affects people and their property. So there's a natural hazard and then there's a natural disaster, right? So let's talk about earthquake hazards and impacts, that is effects, right? So firstly, this is a primary hazard. It's what happens first. Ground shaking, so you know this is potential danger. Surface faulting, again potential danger. Now secondary hazard is, as the ground was shaking, it has led to failure, so ground failure. Then soil liquefaction, as the term suggests, soil loses its solid properties and becomes more liquid-like. Then landslides and rockfalls. Mud flows. Tsunamis. So these are the earthquake hazards that you need to be aware of. Now let's move on to effects of earthquakes. Firstly, we have total or partial destruction of building structures. Then we have interruption of water supplies. Then we have the breakage of sewage disposal systems because of the sheer power and strength of the earthquake. Then there's going to be loss of public utilities such as electricity and gas. Then there's going to be spread of chronic illness. A chronic illness means a long-lasting or sort of permanent illness. And this could be due to inhaling some certain toxic materials that are released during earthquakes. And so yeah, the release of hazardous material. And the last effect of an earthquake would be fire. So these are the hazards and effects of earthquakes. Now, earthquake damage can be a lot or a less, and the extent of earthquake damage is, influenced by a number of factors. The first one is the strength of the earthquake. So, as always, as it is, the stronger an earthquake, the greater the impact. Secondly, the population density. So if the earthquake occurs at a place where there's a dense population, then you can say that there's more impact than at a place where there's less population. So for example, if an earthquake hits the Tokyo region of Japan, it could inflict far more damage than one that hits an area of low population and low density. Next, the time of the day. So if it's sort of rush hour when a lot of people are returning home from office, it may cause more deaths than one at a quiet time. Then the distance from the center, distance from the epicenter. So the closer you are to the epicenter, the more damage is done. Then there is the types of rocks and sediments. So if there's loose rocks and loose sediments, then it may act like liquid when it's shaken, and solid rocks are much safer, and buildings should be built on areas where there is solid rock, because if it's built on weak rock and weak sediment, then the building will collapse easily. So these are the factors that influence earthquake damage. Now, you may have heard of some people who live near earthquakes, right?